Hi guys, so now you can see two different images. The left one is random image, which means each pixel's value is random. And the thing is, this random image is drawn in the draw function. So per each frame, the random image is changing, right? So each pixel value is totally random. But how about the right one? Right one is called the Perlin noise. This is random image, but it seems to have some kind of texture information. So here the texture means some pixels value is related to the neighbors. And the second image is random, but it doesn't change. Although we are calling the random image per each frame in draw function, the image doesn't change. And if you look into carefully the image, I'm going to move the mouse a little to the right, and the image seems to go to the left, right? If you go to the right, if you move the mouse to the right, the image seems to go to the left, right? So the second image, the right image is random image, but each pixel's value is random, but it doesn't change. So this kind of thing is called Perlin noise. This is different with a random function. So in this video, let's look into the Perlin noise deeper. So this is processing main side. So random function, and we'll see noise function too. So this noise function is about the Perlin noise. So let's read the description. So random function generate random numbers. Yes, right? Each time the random function is called, it returns unexpected values within the specified range. That's what you know already, right? And let's go to the noise function, Perlin noise. So noise function returns Perlin noise value at specified coordinate. In this statement, I think the most important part in this statement is this one. So Perlin noise gives some value at specified coordinate. Let's read this paragraph till the end. So Perlin noise is a random sequence generator producing a more natural harmonic succession of numbers than that of the normal random function. Ken Perlin made it in 1980s, and it is used texture, some shape, terrain, and other seemingly organic form. What this paragraph means? So let's look into Perlin noise with an example in this video. Okay, this is first example using Perlin noise. So this image is a random vertical lines. So it's totally random. So the vertical lines point of X is random. But what about this? This is also random vertical lines, but it has some kind of smoothness, right? So it is random, but it seems to have some kind of thing, right? So I made this one with Perlin noise. So let's make this one with me. So I'm gonna move this one here. So at first, use random function to make random vertical lines. So I'm gonna open the canvas into 600 size, and let's go into the draw function. I'm gonna use float variable for the X, and let's clear the background with white colors, and let's get the random value using random function. So random 1 gives us the random number 0, 2, 1, right? And we have to times width, because we are gonna make a random number 0, 2 width. Then let's draw the line x, 0 and x, height. This is vertical lines, right? So okay, let's run this code. This is random lines, right? So yeah, right. But we want to make this kind of things. So it's really hard to make this one with random function. Instead of that, let's use Perlin noise. So I'm gonna change this code a little more. I need to I need to declare the variable for the polynoise. I'm gonna say x of equal 0,0. Let's initialize it into with 0. And I have to draw, let's use this. If you press the mouse, I'm gonna use kind of some polynoise here. Else I'm gonna draw the random lines like this. And so you have to make some code here with a polynoise. I'm gonna say x equal, so this noise function is about the polynoise, and noise function will give us the float number 0 to 1 with these parameters. I'm going to explain what this parameter means. And times width, because random of 1 give us a random number 0 to 1, and noise function returns always 0 to 1 with this parameter. So if you give, and I'm gonna draw the line, and I have to change the x of variable. So x of variable is the parameter to the noise function, right? So I'm gonna change this one into a little different numbers, kind of. So I think that's it. So if you press the mouse, I'm gonna draw the polynoise image, or I'm gonna draw the image in random image. So let's run it. So this is random vertical lines, but if I press the mouse, that's random lines, right? But it's kind of some harmonic things. So this is called polynoise. So let me explain the polynoise. Do you remember this sentence? So noise function returns polynoise value. So this value will be 0 to 1, and at specified coordinate. So a specified coordinate is the parameter of the noise function. So let me explain this one. So this noise function will give us 0 to 1 float value. But if parameter is same, the random number will be same. Do you understand? But the random function is generating the random number without respect to the parameter, right? This parameter is just boundary. So this random number will generate 0 to 1. If you change this one into 10, this random function will generate 0 to 10, right? This random function will generate 0 to 1 random value. But noise function will give us always 0 to 1 float value. But if the parameter is same, the noise function will give you all the same random values. That's the key point. Here, the previous application example is one-dimensional polynoise example. So from now on, let's make two-dimensional polynoise. So I'm gonna make this kind of images using polynomial function on 2D space. So let's make this code. So first of all, I'm gonna make such a random image. So I'm gonna declare noise variable here. So let's make two-dimensional random image. X is less than with x plus plus. And inside the for, let's use one more for loop. Plus plus. So in the for body, let's make noise values with random, right? So random width divided by width. This will give us a random number 0 to 1. And after choosing the variable, the random value, let's set the stroke colors with noise values. So noise value is 0 to 1, so we need to times 255 to set the stroke color, and use the point function x, y. So let's run this code. So this is random image, right? This is what you want. This is not what you want. So let's use Perlin noise like the previous one-dimensional array. So let's use it. So if you press the mouse, I'm gonna make a Perlin noise value, else I'm gonna make such a random image like this. And let's use noise values here. I'm gonna make noise values with Perlin noise. But let's go to the processing.org. So this is about the Perlin noise. Let's see the syntax. So if you give just one parameter to the noise function, that's one-dimensional example. So if you give 2 parameters, that's 2-dimensional. 3, that's 3-dimensional Perlin noise. So let's use the code 2 parameters, right? So the first one should be about x, and the second one should be about y. I'm going to give mouse x plus x because it's dependent on the mouse point. So if you move the mouse, the Perlin noise will, the final image will be translated with these parameters. And we can give one more value with respect to the mouse y and y point. I think I'm almost done. So let's run this code. So if you press the mouse button, this is kind of Perlin noise. Yeah, right. But I think the parameter is too big. So let's make one more variable. Noise scale. Let's give 0.1, and let's times the variable noise scale variable to the x and to the y too. Let's run it. If you press the mouse button, yeah, it's a little different, right? So if you make these things smaller, you can see the difference. So this is Perlin noise. So let's move the mouse to the x or to the y. If you move the mouse to the right, the texture final noise image is translated to the left, right? That's the Perlin noise. If you move to the bottom or change the y coordinate, it seems to moving, right? That's the Perlin noise. Let's make it smaller. So if you make it smaller, the Perlin noise is kind of, can you see the difference? The texture value is diverse, it's very large, right? If you make it small, the texture information is fine, the finer, right? It's really fine. So you have to change the scale variable as what you want. So this is the example for the Perlin noise 2-dimensional. This is another example using Perlin noise. So I have drawn a random line, but here the random means the center, the midpoint of the line is random, and the angle, the orientation is random. So I have declared these 3 variables. Angle noise is a variable for the angle, and x noise, y noise is for the center of the line. So inside of function, I have declared some variable and initialized it. And let's go to the draw function, which is main. So here I have used noise function here. So this center x and center y is the center of the line. So let me say, so if you draw one line, here is the center, right? So I've made the center with noise function. And after using this noise function, the x noise variable and now y noise variable is changing a little. And then for the angle, I've used angle noise variable, right? And I've changed the angle noise too. So this is all for noise function, Perlin noise function. And do you remember this statement? Using sine and cosine to find the end point. So to draw the line, you need two endpoints, right? So from the center, you can find the x1 and y1 and x2 and y2 using cosine and sine function, right? So this 3 line is to find x1, y1. This 3 line is to find x2 and y2. So if you found two endpoints to draw the line, you can draw it, right? And I've make the line color in random, and I've drawn the line. That's it. So let's see what will happen. So here to draw the line, I have used the alpha for the transparency to get this kind of result. Let's watch this in a little more. Okay, I recommend you to use those functions to make your own artwork.